Hello and welcome. Let's dive into an exciting journey where we explore trigonometric functions. Have you ever wondered how we can apply angles in mathematics beyond just simple geometry? Well, trigonometry is your answer. In this video, we'll extend the basic trigonometric ratios like sine and cosine to all real angles, not just acute ones. Mathematical explanation. Let's begin by considering a unit circle, which is a circle with a radius of 1 unit centered at the origin of the coordinate plane. If we take an angle x and let's say it's in radians, the coordinates of the point on the unit circle corresponding to this angle will be a, b. In this case, we define cos k smiley equals a and sin k smiley equals b. Key formula: cos squared x plus sin squared x equals 1, which is known as the Pythagorean identity. This equation holds true for any angle, and it's a fundamental property of trigonometric functions. Now that we know how to define sine and cosine functions on the unit circle, let's talk about quadrantal angles. These are special angles like 0 degrees, 90 degrees, 180 degrees, and 270 degrees, or their equivalent in radians 0, pi over 2, pi, and 3 pi over 2. Mathematical explanation: at each of these quadrantal angles, we have easy to remember values for sine and cosine. Cos of 0 equals 1, sin of 0 equals 0, cos of pi over 2 equals 0, sin of pi over 2 equals 1, cos of pi equals negative 1, sin of pi equals 0, cos of 3 pi over 2 equals 0, sin of 3 pi over 2 equals negative 1. Key formula: these values repeat every full revolution, and the trigonometric functions are periodic with a period of 2 pi. Moving on, let's define the reciprocal functions, which are just the inverses of the primary trigonometric functions. These include cosecant, secant, and cotangent, and they're very useful in many areas of mathematics. Mathematical explanation: here's how they're defined. Cosec of x equals 1 over sin of x, sec of x equals 1 over cos of x, cot of x equals 1 over tan of x. Key formula: just like sine and cosine, these functions have periodic behavior and are undefined at certain points. For example, cosecant is undefined where sin of x equals 0, and secant is undefined where cos of x equals 0. Now, let's explore how these functions behave in different quadrants of the unit circle. The sign of the trigonometric functions depends on the quadrant in which the angle lies. Mathematical explanation: in the first quadrant, from 0 to pi over 2, all functions are positive. In the second quadrant, from pi over 2 to pi, sine is positive, but cosine and tangent are negative. In the third quadrant, from pi to 3 pi over 2, sine and cosine are negative, while tangent is positive. In the fourth quadrant, from 3 pi over 2 to 2 pi, sine and tangent are negative, while cosine is positive. Key formula: thus, sin of x is positive in the first and second quadrants, while cos of x is positive in the first and fourth quadrants. Understanding these signs helps us solve equations and analyze functions. Next, let's look at the domain and range of these functions, which will help us understand their behavior better. Mathematical explanation: both sine and cosine functions are defined for all real numbers, but their values always stay within the range of -1 to 1. In contrast, tangent and cotangent functions are defined for all real numbers except at odd multiples of pi over 2, and their range is all real numbers. Key formula: the secant and cosecant functions are undefined where cos of x equals 0 or sin of x equals 0, respectively. Their ranges are y greater than or equal to 1 or y less than or equal to -1. Finally, let's put everything we've learned into practice by solving a few trigonometric equations. Solving these equations involves using the unit circle and the periodic properties of trigonometric functions. Mathematical explanation: for example, If we're asked to find the angle x for which sin of x equals 1 over 2, we can refer to the unit circle to find that x equals pi over 6 or 5 pi over 6. Keep in mind that trigonometric functions are periodic, so the general solution will be x equals pi over 6 plus 2 n pi, where n is any integer. Let's quickly revise what we've learned today. We've explored how trigonometric functions work using the unit circle, how to calculate their values, and how their signs change in different quadrants. We've also seen how to solve trigonometric equations and understand their periodicity. Mathematical closure. Trigonometric functions form the foundation of many advanced topics in mathematics, including calculus, physics, and engineering. I hope you now have a solid understanding of how they work and why they are so important. In the next video, we will explore more advanced topics such as trigonometric identities and solving more complex equations. See you then.